with review on multiplication. So I'm looking at the following problem. I'm going to draw a stick from my class to have someone come up and solve this problem on the board for us. Well, I don't want to do that one. I think that's one we did yesterday. Let me do a homework one. Kelly, can you draw a stick for me? Over there.
Okay, so we put the value of the 3 right here, the value of the 4 right here, and then the value of the 6. And then we do 200, and then we do 70, and then 3. And then we do 300 times 200, 300 times 200, which is 3 times 2 is 6, and then add the 4 zeros. And then 300 times 70, 3 times 7 is 21, and then add the zeros. And then 300 times 3, 3 times 3 is 9, then add the zeros. Then we do 40 times 200, 8, and then add the zeros. Sure. Let's erase this. Then we do 40 times 70. We do 4 times 7 and add the zeros. We do 40 times 3, which is 12, and then add the 0. And we do 6 times 200. 2 times 6 is 12, and then we add the 2 zeros. And then we do 6 times 70, which is 42, and add the 0. Then we do 6 times 3, which is 18. And then we add these 3 together, these 3 together, and these 3 together. So we add 60,000 plus 8,000. I do this in different colors so it shows up. And then 8,000. And then 1,200. And we add all these together. Okay, then we put this number right here. And then we add these three numbers together. What? Oh. There. So. We add all these together. 12. And we put this number right here. Then we add these three numbers together. And then we add these three numbers together. What? Oh. And then
I think the numbers may be a little shifted. You're adding, line them up. You're adding 9 plus 4 plus 1.
oh.
Your 4 was right. Yeah.
Still an eraser.
It's kind of hard to see them up on the smartboard or the Promethean board. 9 plus 4 plus 1.
And that's the answer. Oh, but yep, I am. I guess I'm not ready. What, 94,000? Mm-hmm.
Okay, so that is the model method. When you're adding, it's the best practice, though, is to make sure you line everything up so you know which place each number belongs. 94,458. Okay, so that was the model method. Now we're going to use standard algorithm. Miss Kelly, you want to draw another stick to see who our lucky person's going to be today?
Number 9. Okay, so first we have 6 times 3, and that's 18, and you carry your 1, and then 6 times 7 is 42, plus your 1, so that's 43. And then you do 6 times 2, and that's 12, plus 4 is 16. And then, so I don't get confused, you put your 0 down there, and then so you don't get confused, you should erase those numbers up there. Because you're moving to the next place, we're moving over to the 4, so you need to put the 1 there, or the 0 there. And then, so we're at the 4, and then you go back to the 3, so 4 times 3 is 12. You want to make sure you're lining them up good right there. And then 4 times 7 is 28, plus 1 is 29. And then 4 times 2 is 8, plus your 2, you're going to put 10. And then now, instead of just putting 1 0, now that you're here, you want to put 2 zeros because you're in the hundreds place. And then go back over and erase this. And then you do 30 times 3 is 9. Oh, darn it. This one. Okay. And then, so we do 3 times 3, which is, oh, goodness. Stay. Okay. 3 times 3 is 9, and 3 times 7 is 21. Put your 2 right there. 3 times 2 is 6. Plus 2 is 8. And that answer is going to be, here your 8. 3 plus 2 is 5. 6 plus 9 is 15, plus another 9, 24. And then 2 plus 1 plus 1, 4. And then 1 plus 8 is 9. And that's your answer.
And does it match the model?
Yes.
Okay, no pause. Middle button. Thanks. Problem set lesson 8. Number 1. I want you to solve that problem. It says an estimate for 213 times 328. We've already done this a whole bunch of times. What would my 213 become, everybody? 200. And what would my 328 become, everybody? 300. And I don't know if you've noticed, but they do this little squiggly looking thing. A lot of times, that means approximately. There's a little squiggly, not an equal sign. So 2 times 3, you multiply the front numbers. You multiply all numbers together that aren't 0. 2 times 3. I thought you just went to the bathroom. Did you just go to the bathroom? Number 2. 6. How many zeros do I have? 4. Add my 4 zeros. 60,000, or we could say 6 times 10 to the power of 4. 4 zeros. So based on what you just learned from my 2 students, I want you to try to solve this problem. Okay, so we've solved the problem. We're back online here, so time turned off. We've solved the problem, and our answer is 69,864. Now the question is that a reasonable estimate? Question is this 60,000 a reasonable estimate? And the answer is, so I'm going to have you take a few minutes to talk with your neighbors to discuss why you think that might be a reasonable estimate, and then I'm going to draw sticks to have someone tell us what they talked about. Okay, so here's the dilemma. My initial thought, when I'm thinking through things, and this is when you have to change your thinking, do a complete shift, so you might want to pay close attention, especially if you're eating sunflower seeds on my floor, because you're going to come clean up shells afterwards if you're eating them in here. If I were to round this number, what would I end up with?
You would end up with 70,000 because 9 is bigger than 5.
Yeah, so the problem is that I didn't get 60,000, did I, when I rounded? So here's what they want you to do. They want you to look at these 2 numbers. Did I have to round down when I did the 213? Did I have to round down to 200? Yes. When I rounded 328, did I have to round down? Yes. So will this number be greater than or less than the actual product? What's going to be greater? Okay, the product will be greater than the estimate. Hey, pay attention. This number, the product, will be bigger than the estimate. Is our answer bigger than the estimate? Yes. Therefore, it's a reasonable estimate. That's what they say. If you round down and round up one number, then usually it'll be close to it. If you round both of the numbers up, Will your estimate be greater than the product or less than the product? Yes, if you round both numbers up, then your estimate's going to be greater. That means if you get this answer and it's bigger than your estimate, then you've done something wrong.
What happens if you round one up and one down?
That's what I say. You'll get close. You'll get closer to the answer.
How would you actually know
Because it'll be almost the same answer. That's what I thought too. That's the first question I asked, and that's my assumption right now because I couldn't really find anything to help me much with it. But I tried a few problems out. When I rounded one number up and one number down, I was really, really, really close to the actual answer.
When I estimate my number and then I multiply it, I kind of look at like what you were saying. If I rounded down, then my answer would be more than my estimation. I kind of use that. So if it's less, then I know I did something wrong. That like is that a good strategy or not? Did you get the right answer or no?
Well, let me show you this next problem because I was okay with the 69,000 because I thought, okay, well, and then this next problem is the one that kind of stumped me on all this. So we'll see if you guys can figure this out. So first we're going to estimate. So I'm going for people on the floor. Number 5. What's my 600 going to become? It's okay. I'll just tell you. Look at the neighbor.
Yeah.
Is it 5 or greater?
No.
Is the neighbor bigger than 5? 700. That's fine. I make mistakes all the time up here. And so in my class, at their desk, 15, what's the second number going to become? Okay, 400. So our smart estimate is on the floor. Number 6, what do you think? 28. And then how many zeros do we add?
4.
So 280,000. Did we round these numbers up, or did we round these numbers down at their desk? Number 18?
They rounded up.
Okay, we rounded them up. So that means, what does that mean about my estimate? Is it going to be greater than or less than my actual product?
It will be less than your estimated.
Well, if you round these up, if these go up, what's that mean? It's going to be,
That one will be higher.
this one will be bigger. Yep. So this one's supposed to be solve at your desks, and then I'm going to have someone from the floor come up and solve this multiplication problem. So solve it.
Okay, so you're going to do 2 times 2, so that's 4. And you're going to do 6 times 2, which is 12. Then you do 6 times 2 again, plus 1, be 13. And you have to put a 0. You do 7 times 2. 7 times 6, which is 42, plus 1.
and then 7 times 6 again, plus 4, 6. And since we're in the hundreds place, you do 2 more zeros. 3 times 2, 6. 3 times 6, 18. Plus 1, 19. Then you add these.
Okay, you guys agree? So the question is was this right here a reasonable estimate? Yes or no? Yes, because 280,000 is greater than, and right now this is just based on information we can find. I might come back to you tomorrow and say it's something completely different, but that's the way it goes. My homeroom, we did the first 2 on the problem set. I'm going to have you finish those boxes. So your assignment is 1A through 1I. Okay, so problem set, we've already done 2 of them. Lesson 8. And that is your homework.